Hi, my name is Priya Pusari, and I am a firmware applications engineer supporting the SmartRAID product line at Microchip. In this video, you will be introduced to the basics of shingled magnetic recording drives, commonly known as SMR drives. Topic that you will learn about SMR drives today will be why, what, pitfalls, and variants. Why are SMR drives used? SMR is well suited for organizations that store massive amount of data at low cost. Photos, videos, and documents on cloud storage are one such example. Today, millions of SMR drives are used as USB backup drives as they offer more capacity without increasing the price. SMR HDDs provide unheard of pricing with vendor offerings debuting as low as few cents per gigabyte. What is an SMR drive? Before we dive into details of SMR drives, let us learn a few basics of drives. What are tracks? A track is a path on surface of a disk on which information is magnetically recorded using write head. Recorded information is read using the read head. Conventional recording methods have a small space between the tracks to reduce magnetic interference. Conventional HDDs do not overlap tracks. SMR is a new HDD recording technology designed to increase density beyond the limits of traditional perpendicular magnetic recording. Minimizing the read-write heads allowed manufacturers to progressively place the tracks closer together. Advances in head technology and signal processing enable the read element to pick out data in spite of interference from adjacent tracks without compromise to data integrity or reliability. The read head is much thinner than the write head, so it can read data more effectively through the narrow overlap disk tracks without any issues. SMR tracks partially overlap similar to roof shingles. SMR achieves higher areal density by squeezing tracks closer together. Leveraging the same mechanics used by CMR drive, capacity is increased by 15 to 20%. Pitfalls of SMR drives. The write head is wider than the trim track, hence, when writing data into the track, data on the following adjacent tracks will be destroyed. As a result of this, the following adjacent tracks needs to be rewritten. When the data in the following track is rewritten, the SMR drive would need to correct the data in the subsequent track and so on, repeating the process probably until the end of the drive. How to avoid the pitfalls? Design of bands. A certain amount of consecutive overlap tracks are packed as band. The last track in the band is not overlapped by others. Each band can be individually modified without interfering with other bands. Grouping tracks into bands optimizes the number of tracks that needs to be rewritten. This avoids rewrites until the end of the drive. The architecture of the band is customizable for the application. Let us now see a quick example on how to update a band with new data. Read old data, merge with new data, write new data, refreshing old data. There are three variants of SMR drives. Drive managed. Manages all requests from the host, like any traditional HDD today. No host change required. Underlying SMR nature is completely hidden from the host. Backward compatible. Most simple to deploy. However, the background housekeeping task that these drives must perform result in highly unpredictable performance unfit for enterprise loads. Extremely effective in personal computers. Host managed. Host is responsible for everything ranging from managing data streams to read-write operations and zone management. Not compatible with host systems that are not SMR aware. Depending upon the system architecture, implementing these modifications may seem like an onerous task, yet once developers gain SMR familiarity and optimize their applications for sequential writing, they can take advantage of unsurpassed level of reliability and quality. This gives the drive more predictable performance and more likely to be seen in hyperscale applications. Host-aware drives. It is a combination of drive managed and host managed. Backward compatible. Gives the host some control. Self-managed. Implements the new ZBC, ZAC standards. Host uses the new command set to optimize the drive behavior. Model of choice for most clients and traditional enterprise systems. Our smart product family 1100, 2100, 3100 supports drive manage, host manage, and host our SMR drives. For further details, please visit Microchip website. Thank you for watching.